Having understood the nature and impacts of pollution, we now turn to the second module of this course: pollution prevention, control, and management strategies. The objective here is to explore how society can reduce, remediate, and responsibly manage pollution using scientific, engineering, and policy approaches. Principles of pollution control. Effective pollution management relies on three central principles. Prevention at source, stopping pollution before it occurs, for example, using cleaner fuels or designing processes that generate less waste. Control during release, capturing or treating pollutants before they enter the environment, for example, scrubbers in smokestacks or wastewater treatment plants. Remediation after contamination, cleaning up pollution after it has already entered the environment, for example, soil washing, bioremediation, or oil spill cleanup techniques. Air pollution control. Methods of prevention and control include cleaner technologies, switching to renewable energy sources such as solar, wind, or hydroelectric power. Fuel quality improvement, reducing sulfur in fuels to minimize emissions. Emission control devices, installing filters, electrostatic precipitators, and catalytic converters in vehicles and industries. Urban planning, designing cities to reduce traffic congestion and promote public transport. Noise pollution control. Strategies for noise reduction focus on both prevention and mitigation. Urban design, establishing green belts or buffer zones between residential and industrial areas. Engineering controls, soundproofing machinery and buildings, using silencers on engines. Regulatory measures, setting permissible limits for noise in different zones and times of day. Behavioral adjustments, promoting awareness about harmful effects of noise and encouraging quieter practices. Solid waste management. Solid waste poses a growing challenge, especially with rising urbanization. Management strategies include waste minimization, encouraging reduction at source through better product design and responsible consumption. Recycling and reuse, converting waste into useful products, such as recycling plastics, metals, or paper. Composting, biodegrading organic waste into nutrient-rich manure. Sanitary landfilling, disposing of waste in carefully engineered sites that minimize leakage into soil or water. Waste-to-energy technologies, using incineration to generate energy while reducing waste volume. Hazardous waste management. Hazardous waste requires special handling due to its toxicity. Key methods include secure landfilling, isolating hazardous waste in lined and monitored facilities. Chemical treatment, neutralizing toxic substances through chemical reactions. Thermal treatment, incinerating hazardous waste at high temperatures to break down harmful compounds. Bioremediation, using microorganisms to detoxify contaminated sites. 2.6 Radioactive waste management. Radioactive waste demands the highest levels of care because of its long-term hazards. Management methods include short-term storage, storing waste in shielded facilities until radiation decays to safe levels. Deep geological disposal, burying high-level waste deep underground in stable geological formations. Recycling in nuclear industry, reprocessing spent fuel to extract usable materials. Strict regulation and monitoring, ensuring compliance with international safety standards. Policy and technological approaches. Technology alone cannot solve pollution. Strong policies and governance are equally essential. Examples include legislation, enforcing environmental standards, such as air and water quality limits. Economic instruments, taxes on pollution, subsidies for clean technologies, or tradable emission permits. Education and awareness, encouraging sustainable practices among individuals and communities. International cooperation, addressing global problems like climate change or transboundary pollution through treaties and agreements. The role of modern technology. Emerging technologies are revolutionizing pollution management. Sensors and monitoring systems, tracking pollution levels in real time. Artificial intelligence and data analytics, predicting pollution trends and optimizing control measures. Green chemistry, designing chemical processes that minimize hazardous substances. Circular economy approaches, reducing waste by designing systems where outputs from one process serve as inputs for another. Module 2 Summary. In this module, we explored strategies for preventing, controlling, and managing pollution. We examined approaches across air, noise, solid waste, hazardous waste, and radioactive pollution. We also highlighted the importance of modern technology, strong policies, and global cooperation in securing a sustainable future. We have now completed both modules of this course on environmental pollution management. In Module 1, we examined the origins, pathways, and consequences of pollution across multiple environmental media. In Module 2, we explored methods for prevention, control, and management, focusing on both technical and policy-based solutions. As future professionals, your role is not just to understand pollution, but to contribute to sustainable solutions. Remember, prevention is always better than cure, and effective management requires both knowledge and responsibility. By combining scientific understanding with innovative practices, you can play a key role in protecting the environment and promoting a healthier world for future generations. Thank you for engaging with this course.